Welcome to online lectures by CA Studies. For more lectures online, please do visit castudies.lk.
Let's move on to the last section, coefficient of variation. So the coefficient of variation brings together the mean and the standard deviation. It looks at the relative variability of the standard deviation compared to the mean. So this formula again you must memorize. Standard deviation divided by the mean. The spread of two distributions can be compared using the coefficient of variation. The bigger the coefficient, the wider the spread. Example. Suppose that two sets of data A and B have the following means and standard deviation. So, the data set A has a mean or an average of 120 per whatever and has a difference of 50, the standard deviation, and their coefficient therefore is 0.417. Whereas if for B, the coefficient became 0.408. What does this 0.417 and 0.408 mean? The gap between the standard deviation and the mean as a relative term is what they show here. Because they want to see how well the data is spread across the mean. Because standard deviation also is not a suitable method for further statistical analysis. Like perfectly it is not. So but coefficient of variation is definitely is. So if you have a high number or high coefficient of variation, it means you are a bit far from the average. Your numbers, majority of your numbers are a bit far from the average. But if you have a coefficient of variance that is lesser, that means your numbers, your other data is very close to the average or the mean. That is what they mean by 0.408 and 0.417. So what is the closest data set to the mean? B's data set. But if you look at standard deviation only, now standard deviation is also a measure of the difference between the average and the actual values. But when we see like that, there is a big difference in B's data. Saying because of 51, saying that like there's a very big gap between the mean and the actual values when we consider average standard deviation. Right, when compared to B, that's how we can say this is high. Otherwise, just by looking at 51, we can't say whether it is high or low. We have to compare it with another data set. So when comparing it is, so this is 51, this is 50. So it means what? So less, there's a better spread of data in A because it has a less standard deviation. It is less deviated from the average. But if you look at the coefficients, A's data has a high coefficient than B's data. But what is the decision making rule in in coefficient of variation? Coefficient of variations, the decision making rule is lower the coefficient, closer it is to the average. Higher the coefficient, far away from it is far from the average mean. Okay, this is the so they will give two coefficients and tell you which one is far from the average. Then you must select the highest one because that is only far from the average. Or they would ask what is the better decision making spot or decision making proper data set. Is it more valid? Then you could choose the data set that has a lower coefficient because it's close to the average. Now let's have a look at the topic skewness. Skewness in a distribution is just trying to show in a graphical way how the data is spread. So you can mark the mean, median, mode in a graph. If you want to mark it in a graph, you should use the skewing method, which could be symmetrical, positively skewed, or negatively skewed. So skewness is the asymmetry of a frequency distribution curve. See, it's a graph. A symmetrical frequency distribution can be drawn as follows. So you have your frequency here and the data set here, and you draw the symmetrical. So what is symmetrical means? The symmetrical word means, see, equally it is divided into two parts. Can you see when the cursor is moving? Just see the way the cursor moves. So this section is equal to this section. Symmetrical. That is meant by symmetrical. Okay. So properties are the mean, mode and median are the same value. Remember this. In symmetrical distributions, mean, mode and median are the same. It's two halves as mirror images of each other. It's the same. Two halves as it's like a mirror image. Same thing is displayed on each side. Symmetrical. Okay. It's also called normal distribution. Positively skewed distributions. It's more towards the left hand side. Can you see that now this is straight? No, this is straight. Now it is moving a bit to the left hand. See the cursor? It's moving left. Yeah. So the left hand way of moving diagrams or distribution graphs are called positively skewed. So in this situation, the mean, mode and median will have different values. And the mode will be lower than the median. And the mean will be higher than the median and maybe the highest. And it does not have two halves. So you must memorize this because they might ask in the MCQ, what is the mode higher than the median, or is the median higher than the mode, or is the mean higher than the median? And you should be very familiar with the properties of a positively skewed distribution because yeah, it is questionable. Okay. Well, a negatively skewed one is moving towards the right hand side. See, from asymmetrical, so this one is moving towards this way. See the cursor. Okay, this way. Whereas negatively skewed ones move this way. And the mean, median, mode, they are maintained like this. The lowest value is the mean, median is the second lowest, and highest is the mode. See? That's how they have numbered in order because the number line starts 1, 2, 3, 4, 5, 6, 7, 8. Likewise, no. So mean is the first item. So mean will have the least number, least value. Mean will have the least point in the graph. So mode will be higher than the median. Mean will have the lower value than the median, lower than most of the distribution. Because mean is affected by extreme values. Now the extreme values is what I taught, that saying when we have 4, 5, 4 and 5 and 6 and then we have 25 and 100. So these 25 and 100 are extreme values which will adversely affect the mean, bringing it down to lower values than the median. So let's work out the skewness question. Okay, So this is how they are given the exam also. In a quality control test, the weights of standard packages were measured to give the following grouped frequency table. Weight in grams 198 and less than 199. So and then 199 and less than 200. So this is a continuous data. And they have given the number of items with that weight. Okay. Now first of all, since this is a continuous data, they have considered the midpoints in decimals. So, you know, between 198 and 199, okay, so if you take this 198 to 199, the middle value is 198.5 because the gap between 198 and 199 is only 1. But so there has to be a middle value and they have not given greater than or less than. I mean like they haven't given less than or equal to, that equal thing they haven't mentioned. So we are not sure exactly whether it is going to have to include 199 here or not include, but they have included. So we can include the in continuous data basically we can include the final 199 towards the data set. Okay, so it will be 198.5, the middle value. Then 199 to 200, it will be 199.5, 200 to 201, 200.5, 201 to 200 to 201.5, likewise. Then they took the frequency from the question and then they multiplied midpoint by the frequency. And then they took the difference between the midpoint and the mean. They calculated the mean using fx, sigma fx divided by sigma f. And from the mean, they minus the midpoint. Basically, it is 198.5 minus 201.27 is equal to minus 2.77. Then 199.5 minus 201.27 is equal to minus 1.77. Likewise, they took this data value. But then after that, they multiplied this minus 2.77 by the what? They squared it first of all by itself. They multiply it by itself. So I will show what they did for minus 2.77. So basically we have minus 2.77. They first of all multiplied it by itself and then they multiplied it by the frequency of it, which is 3, which gives an answer of 23.018, which is the same 23.0187. Likewise, they have done and taken the total and used that to find the variance. So we know as per the formula of standard deviation, variance formula for grouped data, it is this particular thing divided by the total 300 and that standard deviation will be the root of it, which is 0.78 grams. So there's a gap of 0.78 grams basically per unit from the average. So it's right, it's almost okay because it's 2.77 gap, 1.77 gap. So it's nearly that gap. So so they've considered the mean, right? And the mode, how to consider the mode? First of all, you select the class with the highest frequency. What is the class with the highest frequency? 148, that only has. So that is 201 to 202. Therefore, the midpoint, if you draw the graph, the midpoint will be the will be 201.5. That will be your mode. So the median of the grouped frequency, we learned it can be only established by an algorithm. But in the algorithm, so even though we get the value by a graph, we can incorporate a formula. That is, of course, we identified that the midpoint or the class of the highest median is 201 to 202. So it is starting from 201. So you put 201 as the beginning value. Then add, because definitely it's going to be higher a bit, because the 150, even though they say it's the 150th term, it's actually 300 plus 1 divided by 2, which gives like the 150.5 term, right? So anyway, we then take 150. Now we got by get from the formula n plus 1 divided by 2. Then 150 minus 93 minus 8 minus 3. These top values. If you minus them off and divide by the frequency of the selected model or selected median class, you will get your estimated median value, which you could get from your Argyle graph as well. But you will not have time to do an Argyle graph in the exam. You won't be doing it. They won't expect you to do as well. So, as I mentioned in the tutorial, the steps for finding a median, I did not highlight previously about this method, but you could follow this method. You should follow actually, where you first of all identify that item number from the cumulative frequency. So, your cumulative frequency, it ends at 252. Within that range only 50.5th item is available. Then that particular item is here. The class starts with 201. Then you take 201 here, add 150. That is the 150th item that we found, minus the previous frequencies 93, 8 and 3, divide by 148, the frequency of that particular category. Okay. So with that, we finish the chapter on dispersion, but we will do more questions to make us familiar. What you should do is, first of all, memorize all the formula, understand the meaning of everything. It is only then you can find the right thing. So let's meet at the next video.
Thank you for watching the video. Stay tuned with castudies.lk for more lectures online.